All right, so I know you guys are all ready, so let's loud and clear. Let me hear it. Let me feel it. So, class,
Yes.
Joseph.
Yeah.
Okay, good. All right. So, Angel, Angel,
Yeah.
can I? Okay, good. I'm happy with you. Yeah. All right. So this right here, interpreting integral whose integrand is a rate of change. This is important. Es muy importante. Two notas.
Okay.
Oh, in the thing. Put no. It's in the box. Towards the back. Towards the back. No. In the box right there. Towards the back. And it is 5.3. I put them away yesterday. All right. So now, rate of change is important. Okay, it's going to tell me that I have the rate of change there, the equation for the rate of change at whatever given time. So this is going to be a population and it is growing. Now, this is going to be one of the notes that your guys are going to need because it is one of those things that you just have to know. So that I have that the integral of a to the t dt is going to be a to the t over ln of a plus c. This is on those flashcards. Now, also that 2.867, that is a coefficient. That is a positive coefficient. Anyone know what I could do with that positive coefficient? It's the same thing you guys say to me every time I give you a homework assignment. You say F that, right? Yeah. See what I, yeah.
I thought it was Y.
Oh, okay. F that. So we're going to factor that out. So that can go in front of this integrand here. So I'm going to rewrite. So it's going to be 2.867, and that is going to be from 0 to 5. Is that what that said? I hope so.
Oh yeah.
All right. So now, did I just give you a little rule for that? Yes, I did. So 2.867. Is that correct? 867? 876? 867? Yeah, 867. I don't know why. My head hurts. Sorry. All right. And so integral of that is going to give me to the t over ln of, and from, since it's the definite integral, 0 to 5. Definite integral. That's why there's no plus c, right? Even though I gave you something with a plus c for that, but that's just the rule for that. Yeah. Are you writing down the thingy? Okay. I'm going to pull up my calculator. I know you people are going to do the calculator thing also, right? Pull up your handy dandy calculator, not notebook.
Oh wait, no, I found it.
Okay. You got it?
Where was the 6 7?
Yeah, you are. It says 50.
Alyssa has 50.
Hmm?
Alyssa's on mine. Or I took Alyssa's. I don't know.
Yeah, you took Alyssa's.
Or Alyssa's on mine.
was in her backpack, so now you're blaming her for carrying your calculator?
I think we just switched it up on accident.
Okay,
I'll
so
just take 6-9. because I know
Alyssa,
it's-
yes, Alyssa's 6'9".
Yeah, there we go.
There we go, that's why. All right. So let's do the math. So it was, let's write this out. So 2.867 integrand. Did you really just do the hand thingy right now? Did he really, when I said 6'7", just do the hand thingy? Oh my goodness, stop it.
So like my last name.
It's the only time you. That is not a good thing to brag about. Now, am I showing you guys how to cheat on this? Kinda. We could just put the whole thing in a calculator. When can we do that? All the time when we have a definite integral. Because we're calculating a numerical value. Does that make sense? Calculating a numerical value, we could plug it in the calculator. And especially these ones right here, which is a lot of decibels and all this other stuff. So, control enter. It's 14.661. So for A, find that one right here. Now, B, interpret that in context of the problem.
Can you go back to the we did the LN form.
This,
Yeah, but the actual number.
oh, with the numbers? You know I record these too, right? Okay. But see, Angel's posting it already. Yeah, you don't need to do that. You know, I'll post it for you. So yeah, I know it's important. You know, you got to get those likes, especially for these problems here. All right, we good? All right, so Angel, since you were super excited about posting the math that we just did, can you tell me a story about this problem? Now that you know that, what does this mean in the context of that story?
From 0 to 5.
Okay, what does the 0 and 5 mean?
That is
What's the problem talking about?
it's about the amount of years that passed
Very good. Okay, since.
since 2015.
Very good. So that means that 0 represents and 5 represents
Current time. Or
2020. 5 years passed, right? Okay, so it's 2020. Okay, good. Keep going. Tell me the story.
It has been 14.6 years since. Or it grows at a rate of 14.6 million people a year.
It's not the rate. It's not the rate. Remember, this function gives me the rate because this is the derivative, right?
And here, what's the that's the rate of so if this is the rate of a million people per year.
So if I have the rate and I know the rate is this, but from here to here, if I knew all the rate in between,
It's been 14.6 million people in that 5 years.
perfect. 14.661 million people were added to the population of the U.S. Perfect. Good job. That's exactly what it is. So if the population of the United States starting out at 2015 was 320 million people, Kisnet, you ready? you're going to continue this story. If we knew in 2015 it's 320 million, what do we know about 2020?
It was coming?
I almost heard you.
Wait, how many was it in 2015?
How many? It's in 2015. It's right here. It's 320 million. And the angel said it did what? It what? Grew by 0.661, right? Million. So therefore in 2020, we should have more people. Yes, more people is correct. Can you tell me what the new number would be?
Okay, let me put it in the calculator.
Oh my goodness.
Isn't it just 14%, 13, or 114%? Oh, you're adding?
Yeah, so like 14.661.
So it's just 14 people? The population of
No,
the
no.
United States grew by 14 people?
Yes, it grew,
It grew. It's by millions though.
but how much did we start with though?
Okay.
So it grew by that much. So I mean, if there is, so in those 5 years it grew that much, then how much were there in 2020, 2015? In 2015 there was 320 million. Add the two.
Huh?
You added together.
I would.
14.661 and 320 million.
320 million. 14.661.
Add those together.
That's right.
And add those.
I did. 320 million. 14.661.
Okay, now 14.661 is a million. Million. Worth 14.661 million. So add that to
Oh, so
320 million.
320 million plus 14 million.
Yeah.
No, that's hard math.
Yeah, you got that. Come on.
Hold on, guys. Let me.
Don't put anything on
Don't
here.
forget carry the one.
Yeah, I gotta carry the one. Get the derivative of that. Function. I think it might be 33. No. Yeah.
Wait, yeah.
334 million.
Point.
0.661 million. Ooh, that's a tough one, guys.
Yes. Thank you.
No problem. Anytime.
Okay. All right. See this right here? You're gonna get problems like that where you have to interpret and you have to understand the story that goes along with this. Whenever we're dealing with population increase, decrease, and all that in our growth, what we need to have is also my initial population. That's going to be key to a lot of these. If you have your initial population, we could work backwards out of this to get how much it's growing over that time. But then I have to add it to what my initial was. Hello. Okay. The margin of profit, P prime, okay, in dollars per unit for selling X units of a product given by my function. Suppose 100 units have been produced and sold. Find the additional profit from producing and selling 21 more units. Now, these profit functions are important, super important. See this right here? For those people watching online, I am holding one of the desktop organizers. And for the people actually watching, it's the white one. This right here cost me about $2,000 to make. Can someone tell me why it cost me about $2,000 to make? I have to buy the machinery, right? So I have to buy the machine to be able to make the product, and then the material to make the product, right? That's important. So when we're talking about things like this, and you have your profit functions, you have to include that. But right now, we're saying, suppose 100 units been produced and sold. Okay, we've already done those ones. Find the additional profit P from selling 121 more units. What would my integrand look like now? Think about my integral. What is my integral looking for? Of this is important. Additional profit. So if it's my additional profit, what would that be? Kinda. That's more, right? Additional profit. What would my integral? What would my bounds of my integral be? Okay, so it would be from perfect. That's what I'm looking for. No, that's important when you're reading the wording and identifying what it is I need to write down. Additional profit means I'm starting with 100. Additional means I'm actually going beyond that, so it's from 100 to 121. Now, my function is going to be x to the 1/2 dx. That's going to give me, I get x to the, no.
Like,
3 halves divided by 3 halves, right? But if you're dividing by a fraction, isn't that the same as multiplying by the reciprocal? So 2/3 from there we go. So now I've shown work for my problem. I've done what I needed to do. Now I can do what with it? Can we just put it in the calculator? Yeah. Especially for these ones right here, because I don't want to actually take 100 to the 3 halves, which would be square root of 100 is 10. 10 to the 3rd power is 1,000. 1,000 times 2 is 2,000 over 3,000. No, 2,000 over 3. And then the top would be, what's that going to be, 11? 11 to the 3rd power is, I don't know. So, right here, I'm going to go here, lower 100, x raised to the 1/2 dx, control enter. I get, what's that, 22067? 667. Okay, now, I'm going to expand on this a little bit so you guys can see, because these are profit equations, which is super important. So to figure out how much profit I make per item, I take that number and do what? By 21, right? Okay. You'll see it, because there is going to be problems that you have to. So I make about 10.51. So per item. That is my additional profit. That's how I make per item.
How do you know it's asking per item?
I'm expanding on the question. It's not. But you will have problems that are actually talking about it, and I'm trying to go into the story that goes behind this. My original story started off with this. This thing right here in my hand cost me about $2,000 to make. I need to actually calculate that for my initial profit. So if I try and do my initial profit, it would be from 0 to 100. So that is there you go. From 0 to 100. And we get that number right there. And I'm going to divide that by how much profit do I get on my initial? So for initial, so when you do a cost analysis in business, you calculate how much it's going to cost you for the setup, whatever it is, to actually get what you need. So make your certain amount that you need. Additional profit is what you can make after that. So you're trying to actually go above and beyond to get to that. So when you do your profit function, it's important to actually start it out like this. Okay, that's what I need. Okay, I'm making this to get my profit, and then additional profit is along with that. So if you go into business, you will do this business calculus. Does that make sense? Yeah, hopefully. Because you're going to have cost analysis. So that being said, that's it. Like, share, and subscribe. Homework is going to be due when? Tomorrow.